Have you ever wondered how it all started? Well, how all the galaxies formed? Well, you're in luck because today we're talking about the Big Bang, the beginning of the universe. Well, most scientists have thought of the universe as infinite and ageless until Einstein's theory of relativity gave us a better understanding about gravity, and Edwin Hubble discovered that galaxies were moving away from one another, which does fit previous predictions. In 1964, by accident, cosmic background radiation was discovered, a memento of the early universe, which, along with observational evidence, made the Big Bang an accepted theory in science. Since then, technology like the Hubble telescope gave us a better understanding about the structure of our universe. Recent observations even advocate that the universe is still expanding. But how did the Big Bang even happen? How did the universe form from nothing? Now let's just make sure we know that the Big Bang was not an explosion. It was just space stretching everywhere at once, like a star losing energy to counter gravity. The universe started very small as a hot and dense point, like a supercharged black hole. The universe wasn't expanding into anything, just space. It cannot expand into anything since it has no borders. There is, by its own nature, no outside the universe. The universe is all there is. During the development of this hot and dense environment, energy manifested itself into particles. From gluons, pairs of quarks were created, destroying one another, giving off more gluons. Matter and energy weren't just theoretically equivalent, it was so hot it was practically the same stuff. Let's talk about how it all started and the process it went through. First came the radiation era, which was made up of smaller stages called epochs, which occurred in the universe's first of tens of thousands of years. The earliest was a Planck epoch. No matter existed in the universe at this time, only energy and the ancestor of the four forces of nature: gravity, strong nuclear, weak, and electromagnetic, which was known as a superforce. But at the end of this stage, however, one of the forces left the superforce, gravity. Next came the grand unification epoch, which was named for the three remaining forces. But this epoch also ended up losing another force, strong nuclear. Then, the inflationary epoch began, during which the universe rapidly expanded. This was when the expansion of the universe occurred, from the size of an atom to a basketball. At this time, the universe was piping hot, and it churned with electrons, quarks, and other particles. Then came the electroweak epoch, when the last two forces, electromagnetic and weak, split off. During the next stage, the quark epoch, all the universe's ingredients were present. However, the universe was still too hot and dense for subatomic particles to form. Then, in the hadron epoch, the universe cooled down enough for quarks to bind together and form protons and neutrons. In the lepton and nuclear epochs, which were the radiation era's last two stages, protons and neutrons underwent a significant change. They fused and created nuclei, which resulted in creating the first chemical element in the universe, helium. The universe's new ability to form elements, the building blocks of matter, cued the matter era. The matter era is defined by the presence and predominance of matter in the universe. It features three epochs that span billions of years, the vast majority of the universe's lifespan, including the present day. First was the atomic epoch. At this stage, the universe's temperature cooled down enough for electrons to attach to nuclei for the first time. This process was called recombination, and helped the universe create its second element, hydrogen. This element of hydrogen, along with helium atoms, dotted the universe along with atomic clouds. Within the clouds, small pockets of gas may have had enough gravity to cause atoms to collect. These clusters of atoms, which were formed during the galactic epoch, became the seedlings of galaxies. Nestled inside these galaxies, stars began to form. In doing so, they joined the last and current stage of the universe's development, the stellar epoch. The formation of stars then caused a tremendous ripple effect, which helped shape the universe as we know it. Heat within the stars caused the conversion of helium and hydrogen into almost all the remaining elements in the universe. In turn, those elements became the foundation for planets, moons, life, and everything we see today. This was only possible because of the many stages in our universe's development. While countless questions about the origins of our universe remain, it's only a matter of time for some long-sought answers to emerge.